Is chicken healthier than beef?
No.
Okay. If I eat any amount of red meat in my diet, am I harming my health?
No, I think some red meat is acceptable in a healthy diet.
Are all saturated fats harmful to my health?
Not all of them.
Is a 100% plant-based diet the healthiest diet for most of us?
I would say it depends.
Okay. Does eating a high protein diet impact my kidneys?
The evidence is inconclusive, but suggestive that that is not the case within reason.
Okay. Can red meat fit into a heart healthy diet?
Yes.
Do you need red meat to get iron?
Not necessarily.
All right, let's get started. Hopefully, you're nicely warmed up after those questions. I know that it's tough. Like you want to go into a lot more than nuance in the detail. Why don't we talk about red meat in the public eye and overall health? Because there's definitely a suggestion or a belief that red meat is something that should be a luxury. And actually, if you do include it in your diet, you're probably not doing the best for your health. Where did this come from, and why is it portrayed in this way?
Well, I think the history in part relates to saturated fat because red meats contain saturated fat, which raises cholesterol levels. And I think also there has been a view that red meat has negative impacts on things like risk factors for diabetes and so forth. And mostly that comes from observational evidence. So, population studies where people consume a diet, they report in a food frequency questionnaire in some other way um, what they're eating. And so, one of the problems with that type of study is that people self select. And so, people who eat a lot of red meat also tend to have adverse health habits. And so, they tend to be less physically active. They're more likely to smoke. They have higher body mass index, lower average levels of education. And all of these things are associated with adverse health outcomes. Now, I'm an epidemiologist by training, so my training is in evaluating population based study evidence. And so early on in my career, I got involved in a study comparing red meat to white meat, poultry, and fish with regard to effects on cholesterol levels. And I went in fully expecting that we would see that red meat increased cholesterol levels relative to white meats. And that is not, in fact, what we found. And then subsequently, I've done numerous studies with red meat. And what we find is compared to poultry, as an example, there's no difference with regard to effects on risk factors for cardiometabolic disease, basically cardiovascular disease and diabetes. And so I think that it's complicated. I do think that we don't have all of the answers, but I also believe that in the US, for instance, the average intake of red meat is about 1.8 ounces a day of unprocessed red meat. The question of processed meat is a little more complicated, but I think that that is a reasonable intake. I'm not suggesting people go out and eat a lot more than that, but from the studies that we've done, eating that quantity of unprocessed red meat does not adversely affect cardiometabolic risk factors, but with the caveat, it always depends on what you compare it to. And so I do believe that the dietary guidelines for Americans, and they're similar in other countries, that emphasize whole grains, fruits and vegetables, nuts, seeds, legumes, non tropical oils, and I would add seafood to that. Those are reasonable recommendations. So I'm not suggesting people eat more red meat,
Mhm.
but I am suggesting that red meat can be part of a healthy diet with an emphasis on unprocessed red meats.
Let's dive into a bit more around these observational studies. Our audience are not largely research based, and a lot of people may not have read a full study before. So, when we discuss observational studies, it might not be the audience's understanding that we can control for some of those risk factors that you mentioned earlier amongst people who tend to consume more red meat. So, if we look at those red meat consumers and we can control for some of those confounding variables like smoking, exercise, etc., that would bring someone's risk of heart disease higher, what do we see?
Well, the difficulty there is when you say control for, what you mean is statistically control for. And so I have a story that I tell a lot. In 1996, I went to the International Congress on the Menopause in Sydney, Australia, and the keynote speaker started her talk by saying the question at this point is not whether postmenopausal estrogen protects against heart disease. We have 40 observational studies that shows that women who take postmenopausal estrogen have 40% lower risk for heart disease. The question now is how it works. And so then sometime later, a study that both of us were involved in, the HERS trial, showed, in fact, that women after myocardial infarction, a heart attack, given estrogen, postmenopausal women with a progestin, were not protected. And then subsequently, the Women's Health Initiative study confirmed those results. So postmenopausal estrogen was not protective. So then the question is, well, why? Why did these observational studies suggest one thing, and then the randomized controlled trials where there was an intervention, and the intervention was randomized? In other words, people were selected at random to be in the control group or the active group. Why did that show something different? And the answer seems to be that statistical control for risk factors was not enough. And there are various reasons for that. We don't measure all of the risk factors. The ones that we measure, we don't necessarily measure with high precision. So if you talk about physical activity, as an example, asking people questions about how active they are is not necessarily a good reflection of how active they really are. And so there are a lot of challenges. And in many cases, these observational studies do give us the right answer, but in some cases they don't. And so the strongest evidence, I think, is related to those places where we have both observational studies and randomized controlled trials to give us the answer. And when those results align, then I think we can make the strongest recommendation. So, as an example, a Mediterranean diet pattern has been shown in a couple of large studies, Predimed and Cordioprev, to protect against cardiovascular events. And so I think we can make strong recommendations about that. I think about other dietary recommendations, we have to be a little more cautious and a little more skeptical if all we have is observational evidence or observational evidence plus evidence from intervention studies that look only at risk factors. So I think some caution is warranted.
Okay. Let's dive into some of those risk factors actually before we go forward, because I've heard you talk about an anagram, an acronym for cardiovascular risks in the past. Is it FLASH GI or FLASH GL?
Flash GLI or Flash GLIC. So I'll
Okay.
list out what those are. F is family history. L is for low HDL cholesterol. A is for age. S is for smoking. H is for hypertension or high blood pressure. And then GLI is glucose, and that's glucose in the blood or sugar in the blood, and it relates to more than just glucose. It's glucose and insulin resistance and sort of regulation of glucose in the blood. And then lipids, ApoB containing lipoproteins. We usually talk about LDL cholesterol, but it's a little more complicated than that. And then I for inflammation, and I would add a C to that for coagulation. So these are all of the factors that have been shown to be associated with cardiovascular disease risk. And some are modifiable, some are not modifiable. And of course, you can't change your family history or your age or what have you. And so those that are modifiable, I think the goal is to maintain them in an optimal or healthy range. And so that's my main focus, is identifying the risk factors and then maintaining them in an optimal range. And diet influences many of those risk factors.
Okay, so if we dive into red meat and we observe, what we look at cardiovascular risk factors through those different components that you've just articulated there, where is the strongest evidence that red meat is actually having a detrimental impact, and where are you satisfied that the effect is either not seen in the randomized controlled trials, or it's neutral?
Well, I would say the strongest evidence from observational studies relates to risk for diabetes. So, higher red meat intake is associated with greater risk for diabetes. And so, when I look at observational evidence, I say, uh, what are the four key elements that we need to consider in evaluating that evidence? So, it's strength, consistency, dose response, and then biological plausibility. And so strength is, how strong is the association? Smoking and lung cancer, very strong association. Consistency, do you find the same relationship across different countries, different investigators, different cohorts? Dose response, is higher exposure associated with greater risk or greater protection if it's a protective factor. And so, with smoking as an example, heavy smokers had much higher risk of lung cancer than light smokers. And then we look at biological plausibility. And that's where sometimes the evidence breaks down. And when it comes to red meat and risk factors for diabetes, the studies that we've done and others have done, acknowledging their limitations because they're intervention studies that are randomized, but looking at risk factors, not actual incidence of diabetes. But the studies we've done have shown that compared to poultry, as an example, you don't see any worsening of risk factors for cardiovascular disease or diabetes when you feed red meat as compared to poultry. Now, there are limitations, so I don't want to say that we have the final answer on this. And there are some proposed mechanisms that would connect red meat intake with diabetes risk. But at least in shorter term intervention studies, we're not seeing any adverse effect. And so, what I would say is that you always have to ask compared to what. So,
Mm.
compared to poultry, as an example, we don't see any adverse effect. Although in observational studies, you don't see a relationship of poultry intake with diabetes risk. You do see that for red meat intake, but I worry that you aren't controlling for everything. Now, if you compare, for instance, red meat intake to intake of plant sources of protein, then that's a different story. And there are mechanisms through which, say, nut intake, as an example, which would be a plant source of protein, may be associated with lower risk of diabetes. So I would say that red meat intake, when consumed in moderation, is fairly neutral. And then there are some other dietary factors that have favorable effects. So you have to consider, always what you're comparing to.
Gotcha. So just to summarize to the audience, because there's quite a lot to unpack there. Looking at observational studies, you do see a connection with red meat consumption and an increased risk of diabetes. When you compare red meat and poultry, you don't see any differences. And just going back to the observational studies, you also don't see that signal with poultry consumption. However, when you compare red meat to plant based proteins, would you say? So, nuts, seeds, soy protein. There is a favorable effect of the plant based ingredients compared to red meat. But there is an increased risk of red meat on the diabetes risk. Have I got that correct?
Right. So red meat compared to poultry, for instance, to me, with regard to risk factors, looks fairly neutral. For plant sources of protein, they often come along with other things. So, legumes, as an example, come along with viscous fibers that
Mhm.
have a favorable effect. Um, Various plant based proteins will have unsaturated fatty acids, and we and others have shown that higher consumption of unsaturated fatty acids improves insulin sensitivity. So, I don't want to give the message that you should just go out and eat as much red meat as you want. You don't need to consume plant sources of protein. I do advise people to follow a healthy dietary pattern that conforms with the dietary guidelines for Americans' recommendations. And I think, on average, the American public is not consuming enough of the recommended foods. Again, I'll repeat that: whole grains, fruits and vegetables, nuts, seeds, legumes, and non tropical oils. So I'd like to emphasize more eating those things, but you can fit red meat into a healthy dietary pattern, and I think that's my message: moderation. Um, Also, we'll talk, I think, later about processed meat. I have more questions and concerns about processed meats, which tend to be sources of saturated fat, sodium, and then have preservatives in them, where I'm not sure we always fully understand the effects of some of those compounds.
Yeah, yeah, we're definitely going to go into that. In terms of the criteria that you mentioned earlier, so strength, consistency, dose response, biological plausibility, is there a dose response with red meat that you've observed at all? So, for someone who is having what you mentioned earlier, 1.8 ounces of red meat, which I'm struggling to convert into a metric at the
About
moment in grams.
about 28 grams per ounce. So I'm
To,
not going to try to do the math in my head, but 28 grams per ounce.
Okay, so that's about 50 grams of red meat per day, give or take, which isn't very much at all. Would you see an increased risk if someone was having, let's say, double or triple that? Is that something that we observe in some of the RCTs?
So in the RCTs, no, but we have to be careful, because in the RCTs, we're really looking at risk factors and not at actual incidence of diabetes. So that's one of the challenges.
Mhm.
In the observational studies, we do see a relationship. Every 50 gram per day increase in red meat intake has been associated with about a 13% increase in risk of developing type 2 diabetes. Having said that, I would also say that we have to be a bit careful, because, again, there may be residual confounding. So, those people who eat more red meat tend to have adverse lifestyle habits. And so, I think we can, to some degree, control for that statistically, but I'm skeptical that we can fully control for all of those issues.
Yeah, yeah. And going back to that point about moderation, so if we agree that the math is sort of right with 50 grams per day, that's about 350 grams per week, which is, a good sized lean steak, let's say, of rump or bavette or whatever lean beef you want to consume. That's not very much. It's about like a good handful per week. Is that the sort of amount that you would say is a moderate amount?
Right. So we say that a serving of red meat is about 3.5 ounces. And so having red meat, say, 3 times a week, one serving 3 times a week, is reasonable level of intake. And the 1.8 ounces a day is the average intake in
Mhm.
the US. But there are some groups who consume quite a bit more than that. So young men, as an example, tend to consume more than that. And so my recommendation is sort of moderation. In moderation, unprocessed or minimally processed red meat can be part of a healthy diet. A lot of the studies that we've done have been with larger intakes, because if there is an adverse effect, we want to be able to pick it up. So we are often feeding people 2 servings a day of red meat, and compared to foods with refined carbohydrates or poultry, we don't see adverse effects on the cardiovascular risk factor profile or the risk factor profile for diabetes. I'm not necessarily recommending that people consume that much. I think to stay within the recommendations, the current level of intake of unprocessed red meat is not excessive.
Yeah, and I know you would be saying this as well, but I guess looking at the totality of the diet is also very important if you are having those whole grains, vegetables, fruit, nuts, seeds, non-tropical oils. That I'm hopefully is going to be ingrained into people's minds by the end of this podcast. Is as important as the dose of red meat if you choose to consume red meat at all.
Yeah, absolutely. A healthy dietary pattern has lots of health benefits. And I would say we don't fully understand all of the health benefits. When you consume those recommended foods, you're taking in all kinds of compounds, things like polyphenols and other compounds that we don't fully understand, but we do know that they're associated with favorable health outcomes. We need randomized controlled trials. I'm disappointed that we don't have more of them looking at actual disease incidents. But having said that, I think that we can make recommendations based on the available evidence while acknowledging the limitations of that evidence.
I want to dive into some of the biological plausibility arguments because certainly from what I hear, people present these mechanisms as almost set in stone that this is what is going on when somebody consumes red meat. I'm sure you've come across this and perhaps debunked a whole bunch of these, but TMAO or trimethylene oxide, red meat being inflammatory, the heme iron perhaps having a negative effect as well. What are some of the biological mechanisms that you've unpacked, and which ones do you think hold true, if any of them at all?
Sure. TMAO, I think, is something that has been studied. We're actually in fairly early days with regard to studying that. And we do see that when people consume red meat, TMAO tends to go up. That's not universal, it doesn't happen in every study. When people consume poultry, it doesn't necessarily go up. But when people consume fish, they're also seeing an increase in TMAO, and fish consumption has been associated with lower cardiovascular disease risk. So there are some proposed mechanisms, and I don't want to discount those, but we don't really see increases at the levels of red meat that are recommended and the average levels that are consumed. And so that's one of the important things. Within a reasonable level of intake, we're not seeing that increase in TMAO. And when it comes to heme iron, there are various proposed mechanisms. But what I go back to always is what do we have with regard to data? And that may be observational, it may be from randomized controlled studies. But I think that for a chunk of the population, the concern is more about not getting enough iron. And so, especially younger women, um, I think also protein intake is suboptimal in a substantial portion of the middle aged and older population. And plant proteins are fine. Plant proteins, you have to consume a bit more of plant protein generally to get the essential amino acids that would be equivalent to the amino acids in either red meat or poultry, as an example. But it's fine. And so, what I say is that when it comes to protein intake, middle aged and older people are probably consuming less than an optimal amount of protein. The recommended dietary allowance is zero point 0.8 grams per kilo per day. I think optimal is higher than that, probably in the range of 1.2 to 1.6. And so, having some animal sources of protein and plant sources of protein will be it'll be easier for someone to get that amount of protein if they combine those sources. Now, with regard to heme iron, I think that for some people in the population, that may be problematic, especially those people who um, may have a genetic variant that causes them to store excess iron. And so that's a small slice of the population. But again, at reasonable levels of intake for most of the population, I just don't think it's a problem. I would recommend, again, a bit outside my area of expertise, but with regard to cancer risk, I would recommend that red meat not be charred, because I think some compounds are generated by charring of red meat that can potentially be problematic. So, how the red meat is cooked and prepared is an important aspect, and is something that people should consider. But you know, with most people and the way that most people consume red meat, uh, 1.8 ounces a day is not excessive.
Okay, okay, that's great. So, sorry, I should have explained for the listeners' benefit. TMAO is a byproduct of gut microbe digestion of choline and betaine, which are some components that you find in these products in red meat. Um, my global hemine, not so much of an issue that we've debunked that or unpacked that. What about saturated fat? Red meat gets the reputation of being very high in saturated fat and something that we should be limiting. Is that true?
It's true, but complicated. And so it isn't just the saturated fat that one consumes, it's what other fats are consumed. And so we know that saturated fats tend to raise LDL cholesterol. Unsaturated fats tend to lower LDL cholesterol. And so when you look at red meat, so I'll take beef as the most commonly consumed type of red meat, roughly half of the fat in beef is saturated. And then about 30% is stearic acid, which is a saturated fatty acid that doesn't raise cholesterol levels. And then most of the rest is 12 to 16 carbon saturated fatty acids that do raise cholesterol levels. But when you put all of that into an equation that predicts the effect on LDL cholesterol, you find that half of the fat is monounsaturated, which tends to lower LDL cholesterol. 30% is stearic acid, that is neutral. And then the remainder is mostly cholesterol raising fatty acids. So the predicted effect is neutral, to have no impact. I will point out that all meats contain cholesterol, and cholesterol has a modest effect to raise LDL cholesterol levels in the blood. And in our meta analysis that we published 2018, I believe, we found the same thing that a meta analysis found in 1997. And that was that each 100 milligrams per day of dietary cholesterol raises LDL cholesterol by about 2 milligrams per deciliter. And I won't try and convert that into millimoles. So there is a modest effect of dietary cholesterol, but in beef, as an example, the fatty acids in beef would have a predicted effect of 0. Now, this past week, I presented results at the American Society for Nutrition meeting from a study where we put people on 2 servings a day of beef compared to 2 servings a day of poultry. And we found that it was a crossover study, so people went through both treatments. What we found is at the end of each, they had exactly the same LDL cholesterol level, exactly the same, to the milligram per deciliter.
Wow.
And that's what we found in a study, much larger study, for which we published the results, I think, in 1999. So we know that poultry versus beef, no difference with regard to effects on LDL cholesterol. But if you compare poultry or beef to, say, nuts or tofu or tempeh or seitan, you'll have a lower level of LDL cholesterol because of the plant proteins and the unsaturated fatty acids in those plant sources that lower LDL cholesterol. But when it comes to poultry versus beef, no difference.
So this is going to be really surprising, I think, for lots of people, because very much like my own experience in med school, I definitely left with this idea that red meat, high in saturated fat, you want to lean more into the poultry and replace red meat with poultry, and that's a better way of eating for your heart health. But this is untrue, and it's not new. Like you just said, from the 90s, we've actually known about the equivalent effects on cholesterol of these two different meat products. I, if you wouldn't mind, for the listener's sake, would you mind just giving us a little bit of a biology lesson in the difference between saturated fats and unsaturated fats as they are in beef? And you mentioned the differences between the 12 and 16 carbon chain lengths of saturated fatty acids and why those may have different biological effects. Because I don't think many people understand the nuance of what you just mentioned.
Sure, and this is a bit complicated, so I hope I enlighten more than confuse here. But there are three basic types of fats: saturated fats, monounsaturated fats, and polyunsaturated fats. So saturated fats are a carbon chain with no double bonds. And so they tend to raise LDL cholesterol. And we know that eating saturated fats lowers the number of LDL receptors on the liver. And when you do that, you raise LDL cholesterol. Unsaturated fats tend to have the opposite effect. They tend to lower LDL cholesterol. And so that's true for monounsaturated fats, like you find in things like olive oil and avocados. And then it's even more true for polyunsaturated fats, like you find in corn oil and safflower oil and soybean oil and so forth. Now, polyunsaturated fats have kind of two main types: omega 3 and omega 6. We consume more omega 6 from plant oils than we do omega 3s, which can to some degree come from plants, but mainly come from seafood. And so omega 3s and omega 6s have somewhat different biological effects. And I've spent a good chunk of my career studying the biological effects of omega 3s, omega 6s, monounsaturated fatty acids, and saturated fatty acids. So, okay, you've got unsaturated fatty acids that tend to lower LDL cholesterol. You've got saturated fatty acids that tend to raise LDL cholesterol. So when you look at the diet overall, it's the balance between those that is most important. And that is something that's missed by many because they focus on saturated fat and say lower saturated fat. Well, in the US, about 11% of energy in the diet comes from saturated fats. The recommendation is less than 10%. And if you were to cut that in half from 11% down to 5.5%, you would lower LDL cholesterol by 3 to 5%. Now, 3 to 5% is important, but I think that that's only part of the picture. If you were to raise intake of unsaturated fats, you would have an equally an equal effect in the opposite direction.
Mhm.
And so, what I say is, okay, we need to be concerned about saturated fat in the diet. We don't want to consume too much of it, but we'd also like to emphasize sources of unsaturated fats. And those are plant sources, things like nuts and avocados and seeds and non tropical oils. And so it's a balance. And I think that the focus has been much too much on just lowering saturated fat and not enough on consuming those
Mm.
foods that tend to lower LDL cholesterol. And I'll point out that there are other foods, viscous fibers like you find in legumes will lower LDL cholesterol. Plant proteins will lower LDL cholesterol. This is a surprise to many people, but all proteins tend to lower LDL cholesterol,
All
but
protein.
all proteins, but the effect is larger with plant proteins.
Huh.
And so I think that we've kind of narrowed in on saturated fats and demonized them. And I think the American public, as an example, is eating more than is recommended. But that's only part of the story. We're not eating enough of the foods that are recommended that will balance that out by providing unsaturated fatty acids, proteins, especially plant proteins, and viscous fiber. And then I'll add one more thing, which is that excess body weight tends to raise LDL cholesterol. It raises triglycerides even more. But when you think about what can you do to manage your cholesterol level, well, in part it's lowering saturated fat and cholesterol intake. That's part of it, but it's also raising unsaturated fats, raising intake of dietary fiber, losing excess body weight, and increasing intake of plant proteins. So all of these things will have effects, and it's the balance that's important.
Great. Okay. So going back to the beef fat topic, you've got these mixture of different types of fats in many different products, including beef. Half the fat in beef is saturated fat, and the rest of it is unsaturated. Have I got that right so
Yeah,
far?
mainly monounsaturated.
Mainly mono. And out of the 50% of which is saturated fat, 30% of the saturated fats are stearic acid. And stearic acid appears to have a neutral effect on cardiovascular health. I believe it's the same saturated fat that you find in chocolate. Is that right?
It is found in chocolate, and the 30%, I can't remember whether 30% is 30% of the total fat
Ah,
or 30% of the saturated fat. It's one or the other.
okay.
But regardless, a chunk of the saturated fat is stearic acid. Stearic acid is actually converted in the body to oleic acid, a monounsaturated fatty acid. And so it has a relatively neutral effect on LDL cholesterol. But you know, we'll call it, roughly 35% or so of the fat in, say, beef tallow is cholesterol raising fatty acids, but they're balanced by either neutral or cholesterol lowering fatty acids. So the fat in beef is not what's raising cholesterol levels. It's mainly the cholesterol content of beef that is raising cholesterol level in the blood.
Very interesting. Okay. So with those collection of different fatty acids, again, we're sort of postulating here or hypothesizing. Perhaps this is why we see a neutral effect in your studies when people consume a moderate amount of red meat.
Right. So in the study I just mentioned, where I presented the results last week, we gave an immoderate amount. We give 2 servings a day of either red meat or poultry. And the red meat did have more saturated fat in it. So, in that condition, about 11% of the energy in the diet came from saturated fat, which is
Mhm.
pretty similar to the average American diet. And in the poultry diet, only 8% came from saturated fat. But because of that balancing effect of the other fatty acids in beef, the effect on LDL cholesterol compared to poultry was neutral. It was, as I said, exactly the same level at the end of our 4 week feeding period.
Wow. Wow. Yeah, I think it's going to be really surprising for a lot of folks here, because of this sort of idea of poultry being a cleaner, less saturated fatty, a meat with less saturated fat in it. So this is really interesting. And in terms of the different types of fats that you find in beef tallow, because beef tallow is having a bit of a moment right now, so this is similar to the fatty acid profile that you just mentioned here. You're not suggesting that tallow is something that we can have in the diet without any negative consequence, or is it something, as long as we're not having it in our coffee, is actually reasonable as a fatty acid, as a fat to use in cooking?
I think that most people are not consuming enough unsaturated fatty acids relative to saturated fatty acids. So I'm not a fan of switching, as some restaurants have done, to beef tallow as compared to an unsaturated type of oil, or an oil that's higher in unsaturated fats. Um, I think that the effect on cholesterol levels depends on the balance. And so um, I also think there are some concerns about reusing cooking oils so that they become oxidized. I think that is a potential problem. I don't know how much of a problem, but I think that's a theoretical concern. So I'm not a fan of using beef tallow for cooking French fries, for instance. And in general, I think French fries are fine occasionally, but I don't think people should be consuming French fries, twice a day, as I know some people who do that. And so I think it's all about balance in the diet. And I think in general, I talk about the recommended foods. And the recommended foods, I'll repeat just for emphasis: whole grains, fruits and vegetables, nuts, seeds, legumes, non tropical oils. And I would add seafood to that. But then we also talk about tongue in cheek, the four white poisons. And I say that as hyperbole. These are not things that you need to eliminate from the diet, but they are consumed in higher amounts than recommended. And that's saturated fat, salt, refined starches, and added sugars.
Hmm.
And so, in the average American diet, for instance, people are eating too much of the four white poisons, not enough of the recommended foods. And so, what I'd like to see is people making shifts so that they're eating more of the recommended foods and replacing foods that are higher in the four white poisons, again, tongue in cheek, with those recommended foods.
In terms of the contribution of foods to the amount of saturated fat that we consume typically in the diet, and I take your point that it's not just about reducing saturated fat in the diet; it's about increasing monounsaturated fats and looking more holistically about what you're including, like whole grains, fruits, vegetables, nuts, seeds, non-tropical oils, and seafood. Um, where is the biggest contributor of saturated fats to the diet if it doesn't appear to be red meat?
A lot of saturated fat is consumed in mixed dishes and foods. Pizza is actually a source of saturated fat. I love pizza. I think in moderation, pizza is absolutely fine. But it's also especially found in processed foods, um, and so saturated fats mainly, but not exclusively, come from animal products, so dairy
Mhm.
products and meats. But they also come from tropical oils like coconut oil, palm kernel oil. And what's happened to some degree in recent years is there's been a removal of trans fats or industrial trans fats from the food supply. And I think that is a good thing. But one of the things that has happened is there's been more use of tropical oils that are more saturated. And so they can be helpful in the sense that, from a food science standpoint, they allow longer shelf life because unsaturated fats tend to get oxidized and you know cause the food to become rancid. And so I do think that the food supply has changed, and labeling really helps with this. And so it is true that in general, people are preferring foods that have less than half of the total fat being saturated fat in foods. And I think that's a good thing. And we've seen average cholesterol levels in the population go down.
Mm.
And partly that relates to removal of trans fats, which raised cholesterol levels. And partly it relates to more unsaturated fats in the diet. And there are other reasons as well. But again, it's all about balance. And so processed meats, high fat dairy products, unprocessed meats, and then tropical oils are the main sources of saturated fat in the diet. And so, it is a challenge. You have to read labels if you want to keep your saturated fat intake at recommended levels, less than 10% of energy. But I think it's just as important to get a balance of saturated and unsaturated fats.
Gotcha. So if we're looking to reduce saturated fats in our diet, which we should be to keep our hearts in great shape and reduce cholesterol, processed foods and these mixed goods that have a collection of other ingredients that we don't really want to be consuming for lots of other reasons anyway, are things that we need to rigorously remove or at least moderate. So they are luxury items that we enjoy once every now and then, like pizza, which I'm a big fan of as well, but not have habitually in the diet every single week. Um,
Yeah, absolutely. And, I would also emphasize more of those unprocessed or minimally processed foods that are recommended that will bring other things like fiber and polyphenols and compounds that we think have benefits and people are not consuming enough of relative to recommendations.
Absolutely. If I wanted to use a bit of, let's say, unprocessed coconut oil in my curry that I'm making with a side of whole grain rice, some vegetables, maybe some tofu in the base, maybe I'm doing like a Thai style dish, is that acceptable? Or do we have to be really rigorous about the use of things like even coconut oil?
Well, again, it's about balance and moderation. So I think coconut oil, which does raise cholesterol levels, it's we've done a study to demonstrate that it's high in a particular saturated fatty acid called lauric acid,
Hmm.
and that raises cholesterol levels. Now, a little bit of coconut oil used in cooking to produce a certain mouthfeel and flavor, that's fine. Actually, uh, virgin coconut oil that has a lot of plant compounds that remain in it would be preferable to more highly processed coconut oil.
Hmm.
But using a little bit of that is fine. I wouldn't consume coconut oil every day. I wouldn't put it in my coffee, which some people do. And so I think that, like saturated fat from meat, for instance, a little bit from a tropical oil is fine as long as you're getting sufficient amounts of fats from non tropical oils as well.
Yeah. Um, we've gone so far into this pod, and I've made the mistake of not actually defining red meat. I've made the assumption that the listener knows what we're talking about when it comes to red meat, and actually, I think a lot of people would assume we're just talking about beef here, but red meat actually encompasses a range of different products, and perhaps we can talk about the difference between unprocessed and processed as well.
Sure. Well, the main red meats are beef, pork, and lamb. And so those are the ones that are consumed most often. There are other things, game meats and so forth, that are consumed, but at much smaller amounts. And beef, I think, accounts for something like two-thirds of the
Hmm.
total red meat intake in the US anyway. And so when we talk about processed meat has been preserved in some way through smoking or addition of preservatives, often addition of salt. And so processed meats frequently are high in salt and high in saturated fat, and then other compounds like nitrates sometimes. And so processed meats, I have more questions about, particularly things like salami and bologna um, that are commonly consumed in the US as lunch meats. They're high in saturated fat often and high in salt and may contain things like nitrates. Hot dogs are another example of something that may be consumed occasionally, but you don't want to be consuming those things too often. And again, I would say I have more questions because of the salt, the saturated fat, and the preservatives than I do about unprocessed or minimally processed red meat. So, by some definitions, ground beef would be considered processed, but by most definitions, it's considered unprocessed or minimally processed.
Okay. So if we're talking through the different cuts of meat as well, so I'm not too sure what the cuts are in America, but the ones we have here are ribeye, sirloin, rump. If I think about the leanness of all of them, a fillet and rump is definitely on the leaner side, and then you've got the ribeye and to an extent sirloin with a big fatty cap. those have definitely got a lot more fat in. Um, are the differences quite stark between those when you actually look at the fatty differences?
The differences in the amount of fat per serving are quite large. And
Sure.
so, if you look at very lean cuts of meat, they're, 5%, 7% fat. And then if you look at ground beef, the typical ground beef sold in the US is about 20% by weight fat. And
Wow.
so, they are different in the fat content. Now, what we've found, and uh, we actually found this originally in a meta-analysis that we performed. We published that paper in 2012. We found that the higher the fat content, um, there was no difference between higher and lower fat content in terms of effects on LDL cholesterol for those reasons that I mentioned. But that was a surprise to me at the time. We didn't put it in the paper
Mm.
because we actually thought it would be too controversial. People would get hung up on that, and that wasn't the main focus. And so we just said, we don't want to go there. So the fat content is not the main factor in terms of raising cholesterol levels. But I think that in general, we should have a balance of unsaturated fats to saturated fats, not just because of cholesterol levels, but fatty acids get incorporated into cell membranes. And so I think it's important to have a balance because fatty acids in cell membranes are partially driven by what you consume. And
Mm.
so, uh, on average, we're not consuming enough unsaturated fats, particularly omega 3 fatty acids like come from seafood. But that's also true, I think, for um, polyunsaturated fatty acids from vegetable oils. Uh, and seed oils have been demonized recently as potentially pro inflammatory and promoting obesity. And it's odd to me because the evidence not only doesn't support that, but the evidence suggests the opposite may be true. And so at the same meeting, I presented other results where we looked at blood levels of linoleic acid, the main unsaturated fatty acid in vegetable oils. And we found the higher the level of linoleic acid in the blood, and linoleic acid is an essential fatty acid, so we don't make it. If it's in the
Mm.
blood, it came from the diet. Uh, Higher levels were associated with lower levels of inflammatory markers. And so that not only doesn't support the seed oils or inflammatory narrative, but it suggests that, in fact, the opposite may be true.
Yeah, there's a very strong feelings out there with paucity of data, which I equally find perplexing. I mean, if there was a strong, evidence base for some of the claims out there about the pro-inflammatory nature of some of these seed oils that I actually prefer not to consume. I love my extra virgin olive oil, so that's my preferred oil. But yeah, people do get hung up about it, and I think it sort of falls into this naturalistic fallacy about the processing of any ingredient, and perhaps that's why people just steer clear of them through a heuristic rather than an evidence-based perspective.
Right. And it's true that things like olive oil tend to be cold pressed. Olives have enough fat in them, you can just squeeze them and get the oil out.
Yeah.
Things like corn, as an example, don't have enough fat that you can just squeeze and get the oil out. You have to extract it chemically. And that's what people object to. But the chemical extractants or the solvents don't end up in the oil that is in the bottle. And having said that, we've studied things like corn oil and extra virgin olive oil, and there was good news for both of them. Corn oil lowered LDL cholesterol more than olive oil, about 11% for corn oil, 3.5% for olive oil. But extra virgin olive oil also lowered heart rate and blood pressure. And
Hmm.
that aligns with what you saw in the Mediterranean diet studies like Predimed. And so I think there's good news for all of them. We also just finished a study recently where we replaced SOFAs, solid fats and added sugars, with avocado. And what we found is lower levels of non HDL cholesterol in the blood. So I think that following a diet that conforms to the recommendations would include things like avocados and olive oil and so forth. Good news for that. But I think there's also good news for seed oils in that higher seed oil intake has been associated with improved insulin sensitivity and actually lower cardiovascular disease risk and lower risk for type 2 diabetes.
Huh. It's a really interesting one. It's interesting what you said about the comparison between the two oils. So olive oil appears, if we just go back to your acronym around cardiovascular risks, it appears to be having an effect in a multitude of different factors: blood pressure, inflammation. I know heart rate is not up there, but something that at least would point in the direction of better heart health. So, yeah, really interesting.
So, again, I think the dietary recommendations, even though the evidence has some limitations, I think they're pretty good. And so, what I recommend is a generally healthy dietary pattern. There are many ways that you can get to a generally healthy dietary pattern. Um, and I don't like demonization of particular foods. I like to have a message of more of what we want to emphasize and then
Mhm.
moderation of those things that we want to consume less of.
What is so special about fish? So we've already alluded to the fact that fish can be quite high in tmao. So clearly that's not having a beneficial effect. Um, Even some of the fish that isn't high in omega 3, typically like mackerel and the small fish, appears to be beneficial. What is it about fish that could be having a benefit on our health?
Well, I think there are two issues. One is that people who are eating a lot of fish may be different from people who don't eat a lot of fish in
Okay, yeah,
various ways. So I think there could be, some residual confounding there.
sure.
Um, and then the other question is, well, if people are eating more fish, what are they eating less of?
Hmm.
And then the third issue is probably long chain omega 3 fatty acids. And when you're talking about lake fish and certain kinds of fish, they aren't high in those. But deep sea fish are higher in EPA and DHA, which are these long chain omega 3 fatty acids that have a lot of potentially beneficial effects that are anti inflammatory, anti fibrotic. And someone who's had a heart attack, for instance, when you give them fish oil, they have less scar tissue that forms on the heart. So the cardiac remodeling looks better. And I think a lot of the potential benefits of omega 3 fatty acids relate to anti inflammatory effects. But just like you have clotting and then clot dissolving, so coagulation and fibrinolysis, you have inflammation and resolution. And I think that a lot of the benefits of omega 3 fatty acids may be on the resolution side. So, production of resolvins that are actively reversing inflammation. And those are very hard to study. And so, even though we've been studying long chain omega 3 fatty acids for 40 plus years now, I think we still have a lot to learn about how they're benefiting heart health. And it's been a rough road for omega 3 fatty acids as pharmaceutical agents, where we've had some studies suggesting benefit and then some other studies suggesting no benefit. But I think on balance, the evidence suggests that we're not getting enough long chain omega 3 fatty acids in the average American diet. And I actually am in favor of measuring the level of omega 3 fatty acids in the blood and
Hmm.
targeting a level. So there's something called the omega 3 index, which relates to the EPA and DHA content of red blood cell membranes. And moving that up to between 8 and 11% is associated in observational studies. So we have to be careful with reduced cardiovascular event risk. And then we have some clinical trial evidence to support that, although I have to acknowledge that it's been somewhat mixed. Um, but I think that on average, people are not getting enough omega-3 fatty acids. Um, fish and seafood intake is lower than recommended, and there is some conversion of plant sources of omega-3s, alpha-linolenic acid, to EPA, but it's minimal. And
Hmm.
so I do think that more seafood consumption, and personally, I like actually measuring the level in the blood, and if it's lower than 8%, raising that up with supplementation.
So, for folks listening, you can do a blood spot at home test to check your omega 3 index level. I believe in the UK it's fairly cheap. It's about 50 to 60 pounds. And you can see where you are on that index. And like you said, boost it if you're not in that 8 to 11% range with either dietary measures or supplementation. I personally supplement with 1.5 grams of EPA and DHA mixed. And I actually recommend that for folks who are 100% plant-based, who may not be able to get it at all from the diet because of that poor conversion that you just mentioned. Is this something that you supplement with yourself and recommend?
Yep, I do supplement, and we recently, I think it was last year, published a review paper that was focused on a US audience, but it was about the commercially available tests.
Hmm.
So omega-3 index is the one I've used the most, but there are others available as well. And uh, I think that I am now convinced that maintaining a healthy level of omega-3s in the blood, and for many people, that means sort of kind of 1 to 2 grams a day of a mix of EPA and DHA to reach that level. But there's a lot of variability. So, just to tell a quick story, Bill Harris, who's a longtime friend of mine, and he's the founder of a lab uh, called Omega Quant, and he co-developed the omega-3 index test with a gentleman in Germany, Dr. Clemens von Schacke. And so he and I were at a meeting, and he had a blood spot paper with him, and he said, "Hey, you want me to measure your omega-3 index?" I said, "Sure." And at the time, I was supplementing, and I was taking 840 milligrams a day of EPA plus DHA. And my omega-3 index came back at 4.6, which is just about the population median. And I said, wow, I expected it to be much higher than that. I guess I need to up my supplementation. And it turns out for me, I had to increase the amount I was taking to get up to that 8% level. And so that's one of the challenges for reasons that we don't fully understand. There's a lot of variability in the level that you end up with in cell membranes for
Hmm.
a given level of intake. And so, from that standpoint, I'm a big fan of measuring it and supplementing to the degree that you need to get up to that optimal range.
Do you think there are individual differences in how people respond to the consumption of red meat?
I think there almost certainly are. And having said that, I don't think we understand too well what those factors are. But like almost everything, um, you get a set of genes from your parents, and there are all kinds of variations in those genes. And that is along with various lifestyle factors and other things like your body mass index and so forth, going to influence the way you respond to a particular diet. And so recently in the news, there's been a lot about ketogenic diets.
Mhm.
There's a certain subset of the population who tend to be lean. So they're on a ketogenic diet for reasons other than trying to lose weight, but their LDL cholesterol level skyrockets. And so this is very reproducible, that a certain percentage of people, not everyone who's lean who goes on a ketogenic diet has this response. I've seen the same thing with coconut oil. I've seen some people consume coconut oil and their lipids don't change very much. Other people consume coconut oil and their lipids skyrocket. And so like everything, there's variability. Some of it's probably genetically determined, some of it's determined by lifestyle and other characteristics. And we don't always have a good handle on what the factors are, which is why it's so important to keep track of your risk factors, because you know adding coconut oil to your diet may seem relatively benign, but in some people it might not be benign.
Yeah. 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 Um, let's say I'm an individual. I've just been seen by my primary care physician. I've got raised cholesterol. My ADLC is high. If I'm lucky enough to get an apolipoprotein B test, then I've got that, and that's raised or non-HDLC. Um, in terms of the strategy that I could be implementing prior to pharmacotherapy, so before I take a statin, just relaying some of the things you mentioned earlier, I want to be ensuring that I'm not consuming too many calories. I am not having too much energy from food. And a great way of doing that is removing processed food, increasing my protein, because protein from any areas appears to reduce cholesterol. I'd love to unpack that a little bit more. Increase my consumption of unsaturated fatty acids, increase my consumption of fiber, and reduce saturated fats. Um, would it be advisable in this scenario, if I'm trying to optimize everything and assuming that it doesn't impact my enjoyment of life or anything else, that I should be taking red meat or just meat out of my diet?
I think taking meat out of the diet, red meat out of the diet, is going to have a very modest effect, because again, the main element of red meat that's raising cholesterol is the cholesterol
Hmm.
content of the meat. So in the average American diet, the recommendation for years was to consume less than 300 milligrams per day of cholesterol. And the average American diet is closer now to 200 milligrams per day of cholesterol. And so if you took all of the cholesterol out of the diet, which would come mainly from dairy products and meats, that might lower LDL cholesterol by about 4 milligrams per deciliter. Now, that's not zero. And having said that, there are other things that you can do, like increasing viscous fiber intake and increasing unsaturated fatty acid intake, maybe losing 5% of body weight if a person's overweight or obese, that are going to have larger impacts. So I think that for me, the emphasis would be more on getting more of the recommended foods, and not over consuming red meat or poultry, but trying to emphasize greater intake of those recommended foods.
Gotcha. Okay. And you mentioned earlier about increasing protein and how that reduces cholesterol. Is that across the board, or are there certain proteins like proteins from plants like soybeans, edamame, those kind of products that would reduce cholesterol further?
Well, it's interesting because it does seem that all proteins, if they're replacing carbohydrate in the diet, will lower LDL cholesterol. But plant proteins seem to have a larger effect, and we don't fully understand why. And so we did a study some time ago, and we had a great hypothesis. And so this is another elegant theory ruined by the pesky data. So we did a study, and I'll describe the study. It's a little bit complicated. So we thought that soy protein was partly lowering cholesterol by uh, binding bile acids. So bile acids are made out of cholesterol, and so they're released into the gut and then reabsorbed. And so if you don't reabsorb them as much, then the liver says, oh, we need more bile acids. And so it uses cholesterol to make those bile acids. And so there's a drug, a class of drugs called bile acid sequestrants. So in our study, we said, okay, here's a group of people. We're going to take some baseline measurements. We're going to give them a bile acid sequestrant drug to see how much LDL cholesterol lowering we get. And sure enough, the drug worked as anticipated. If I remember correctly, it produced about an 18% reduction in LDL cholesterol. Okay, great. Then we had the subjects go through two periods, one where we added milk proteins to the diet, and the other where instead of milk proteins, we added soy protein. And our hypothesis was that soy protein would increase excretion of bile acids, and that would explain the cholesterol lowering effect. And so, lo and behold, the milk proteins did lower cholesterol, and the soy proteins lowered cholesterol about twice as much. So, in rough numbers, let's call it 5% and 10%. But there was no increase with soy protein in bile acid excretion. So our elegant hypothesis was ruined. That wasn't the explanation. We don't know what the explanation is exactly, but we know that's not it. So, Thomas Edison, in inventing the light bulb, did these thousands of experiments. And someone asked him once, you failed thousands of times in trying to invent this. He said, no, I haven't failed. I've just eliminated, thousands of things that don't work. So we eliminated one hypothesis that wasn't the explanation. We really don't know what the explanation is, but it is true for soy protein and for other plant proteins that they lower LDL cholesterol more than animal proteins for reasons we don't fully understand. And having said that, this is one of the reasons that I say, those recommended foods, so seeds, nuts, legumes, and so forth, bring plant protein. They also bring fiber often and unsaturated fatty acids, all of which are things that are going to have favorable effects. But part of the favorable effect is the plant protein.
So in that study, you got an equivalent amount of protein from milk and soy. We know it's not the bile acid impact, so that's not the mechanism. Could it be the fiber in soy or like isoflavones? So some of the phytochemicals that you find in soy products. Could that be some of the reasons?
I have a good answer, no, because we used a soy protein isolate that had the isoflavones stripped out and was an isolate, so it contained no fiber. So it wasn't the fiber, it wasn't the isoflavones, it wasn't bile acid binding. Well, we don't know what it was. And it
Wow.
did, the effect. And just to be completely accurate, although LDL cholesterol is what people usually talk about, I like non-HDL
Mm.
cholesterol better because it's a better predictor of risk. And that's just total cholesterol minus HDL cholesterol. So the effect was, again, about 5% for the milk proteins and about 10% for the soy protein. And it was only statistically significant for non-HDL cholesterol. The difference for LDL cholesterol, I think, was, p of 0.06 or something, which means very close to statistically significant, but it was definitely significant for non-HDL cholesterol.
Gotcha. So, gosh, okay. So we don't know why the plant protein has a more of an effect, because if we're literally just looking, I mean, so the soy protein isolate is just a collection of amino acids that have been derived from soy, and the milk
Right.
protein, I'm assuming you were using like a whey or a casein
It was
powder.
total milk protein, so it's a mixture of whey and
Oh, okay.
casein. And again, that lowered LDL cholesterol because we replaced carbohydrate essentially with milk proteins. And that's been shown in other studies, like OmniHeart is a good example of a study where they replaced carbohydrate, 10% of energy from carbohydrate, with a mix of proteins, and that lowered LDL cholesterol and non-HDL cholesterol. We just don't know why. We don't know why proteins are doing this and why plant proteins seem to have a larger effect than animal proteins. So, if there are any aspiring nutrition scientists out there who want to study this, it's ripe for investigation.
That's super interesting. Let's end on a bit of a protein rapid fire section, because I know you were part of a review paper looking at high protein potential harms, looking at some of the claims that you find not only in the sort of social media sphere, but also in papers as well. I literally just wrote a book called Healthy High Protein because I, like you, feel that middle-aged and older adults could do with more protein, around that 1.2 to 1.6 grams, coming from a mixture of both plant proteins and animal-based proteins for ease. Um, but there is a bit of a backlash because there is a lot of ingrained belief that more protein is going to damage your kidneys, is going to impact your heart, it's going to lead you to have more a high risk of type 2 diabetes. So why don't we go through some of those claims at the moment? Does high protein impact your bone? Does it make your bones more brittle?
In fact, I would say the evidence suggests the opposite. And this isn't my primary area of expertise, but I was recently at a protein workshop where some of the top protein experts in the world attended. We all gave presentations. My presentation related to effects of higher protein intake on insulin sensitivity and kidney function. So I can talk about those in detail, but Dr. Connie Weaver gave a presentation on bone health, and that's her main area of expertise. And her summary would suggest, in fact, that higher protein intake, within reason, is associated with more favorable effects on bone metabolism and outcomes related to bone.
Okay, so this idea that higher protein results in an acid-base imbalance, so you change the sort of pH of your blood, that drives a negative calcium balance, so peeing out calcium. This is completely untrue, and it's not something that we've seen in studies.
And so I'll, defer to other people with more expertise, but Connie did cover that in her talk. And so while there may be some increase in calcium excretion, what is most important is the balance in bone. So bone, the infrastructure of bone is largely protein, and then mineral is laid down, on that protein infrastructure. And so bone health is not just determined by the mineral content, but also by the protein content. And her studies, some of which are animal studies, but using very sensitive techniques, she's also done many studies in humans as well, would suggest that bone metabolism is improved by higher protein intake. And again, when we talk about higher protein intake, I think almost all of the studies are protein intakes that are above the recommended daily allowance in the US of 0.8. But very few of them are above 1.6. And so we're talking about higher protein intakes, but usually still, less than 20% of daily energy or so.
Gotcha. Okay. Why do some people believe that a high protein diet can damage their kidney, and why is that untrue?
Well, this goes back to something called the Brenner hypothesis. I think it was initially published in the 1980s. And when you give rodents a high protein diet, you see increased glomerular filtration rate. And so, essentially, a higher protein diet means the kidneys have to filter out more solutes. And so you have to filter more in order to deal with that higher protein load. And so the hypothesis is that you're overworking the kidneys, and over time, that will damage them, and that can lead to problems. And so that does seem to be true in rodents. But then you look at other species like swine, and you don't see that same effect. And then there have been quite a few studies in humans, but I have to acknowledge that the studies are generally less than 2 years in length. And when you look at those studies in humans, what you see is that you do get an increase in glomerular filtration
Mhm.
rate, but then you don't see that decline over time up to about 2 years of study.
Okay.
Um, and then when we look at observational evidence, there was a paper published fairly recently that looked at healthy adults and adults with chronic kidney disease, so moderate chronic kidney disease, not severe. And in that study, they looked at mortality, and what they found is higher protein intake was associated with lower mortality, especially in the oldest group in the study. And that was true for people with and without kidney disease. And so a higher protein intake was associated with lower mortality up to the highest protein intake group that they studied was 1.6 grams per kilogram per day. And then in addition to that, there was a recent meta-analysis on protein intake and development of kidney disease. And what that study found is higher protein intake was associated with lower risk of developing kidney disease, not higher risk.
Mm.
Now, I have to point out that the highest levels of intake were still less than about 20% of energy from protein. So these weren't very high protein diets, but observational, we have to be careful. But in general, I think the evidence does not support an adverse effect of higher protein intake within reason on kidney health. And so, what I would say is most middle-aged and older adults should be more concerned about inadequate protein
Mm.
intake, not over intake.
Yeah. And finally, looking at type 2 diabetes risk, I think there is this idea of if you have more protein in your diet, it's going to be damaging insulin signaling. I think we can say that about saturated fats. So if you're having excess amount of saturated fat in the diet, it can lead to a higher risk of type 2 diabetes. But and maybe this is where the sort of red meat protein confounding is coming in people's understanding of this. But why is that untrue? Why is a high protein diet between 1.2 and 1.6 grams of protein per day not associated with a type 2 diabetes risk?
So this is where things get a little complicated, and again, it relates to balance. So there are studies that show that when you feed whey protein, for instance, a milk protein, um, weight loss increases insulin sensitivity. But when you give whey protein, that seems to prevent the increase in insulin sensitivity with weight loss. There are also some studies showing directly that higher whey protein intake seems to impair insulin sensitivity, and that would increase risk of diabetes. But here's where it gets complicated. So we did a study, for instance, where we used egg protein and unsaturated fatty acids. And so we replaced 8% of carbohydrate energy with egg protein, and another 8% with unsaturated fatty acids. And we saw a 24% increase in insulin sensitivity.
Hmm.
Now, there was another study in which they used cereal fiber. Cereal fiber increased insulin sensitivity. And then a moderate protein intake, about 20% of energy from protein, um, did not seem to interfere with that increase in insulin sensitivity. So it is true that there are some studies suggesting adverse effects on insulin sensitivity, a key risk factor for diabetes. But when you combine the higher protein intake with cereal fiber with unsaturated fatty acids, the higher protein doesn't seem to prevent the improvement in insulin sensitivity. So it's a little complicated, and it
Hmm.
probably relates to balance in the
Hmm.
diet. And so that's why I say, focus on those recommended foods so you're getting a balance of fiber and unsaturated fatty acids and a higher protein intake, which seems to have some benefits. Um, and I think that the higher protein intake seems to be less of a concern if you're getting enough of the other things.
Okay. On that note, let's ask you your favorite whole grain fruit, vegetable, nut, and seed, and non tropical oil. What's your favorite whole
Yeah.
grain?
So, well, whole grains, I eat a lot of whole grain bread, and I tend to eat bread that has lots of grains in it. So the particular bread that I eat the most of has 21 grains in it, so
Ah,
I can't pick a favorite. It's like trying to pick your favorite child. You know, fruits, I eat lots of fruits. I eat citrus, and I eat lots of berries, which are high in polyphenols. Um, uh, Nuts, seeds, and legumes. So I eat lots of almonds, lots of pecans. As far as seeds go, not quite sure what seeds I eat the most of. And legumes, I try to eat a lot of a variety of beans to get the fiber, and so I try to walk the talk. What I recommend people do, I try to do myself.
that's epic. That's great. We have a thing here at the Doctor's Kitchen called getting your daily BBGs: beans, berries, greens, seeds, and nuts. We try and tick that off, just a handful of each cooked every single day. And it's a
And
nice little reminder.
I should call out avocados. I eat lots of avocados, and so every sandwich I eat has avocado on it.
You must be paid really well. Avocados are pretty expensive over here in England. So
Yeah,
uh,
they're not cheap in the U.S., but I I like them, and nutritionally, we've done studies with avocados. They uh, fill the bill.
yeah, no, they're phenomenal. They're like these are powerhouse ingredients. They're like well, the amount that we tend to spend on supplements, we should be spending on whole foods are that. Kevin, this has been great. Thank you so much for your knowledge. Hopefully people are going to understand the benefits of whole grains, fruits, vegetables, nuts, seeds, legumes, non-tropical oils, and be aware of the four white poisons. Those are phenomenal takeaways.
Great, it's been a pleasure. Really like to get the word out. I am a research scientist, but I don't feel as though my job is done until I've communicated to the people who can use the information.
Amazing. Amazing. If you loved that episode, you will love the full library of podcasts from the Doctor's Kitchen Library. We talk about everything from inflammation, supplements, and food as medicine. Just like this episode right here. You can click it right now and check it out.